Standing 150 metres above the Hierarchy Golf, the Sentinel offers 117 luxury apartments, a gym, a spa, outdoor lawn, barbecue areas, a running track, and a 675 metre square penthouse, which sold for a record $11.25 million New Zealand dollars. The Sentinel building is situated in the heart of Takapuna, with street access from both Huron Street and Northcroft Street. It offers occupants breathtaking views of the Hierarchy Golf in Auckland City. The Sentinel was commissioned by Takapuna Village, developed by Cornerstone Group Limited, designed by Walker Group Architects, and built by Multiplex. The building itself only has a 600 metre square base and cuts into the shallow slope of the site, requiring a 4 metre retaining wall for the basement. The foundations, however, had to be driven 30 metres underground in order to make contact with solid bedrock.
And the building sits here. Okay, doing all this thing. Now that's a big area.
Yep.
So for a start, around here you have a seismic joint. Yeah, and that's about 100, allowing for 100 millimetre movement. Now the building theoretically can do this, but under the wind loading, that it's not allowed to move more than 10 mils. So this tower, being 130 odd metres high, has piles that go down they go over 30 metres.
Okay.
So it's usually the 1/3 of the height sort of thing.
Yeah.
But in this situation, and this is more of a raft foundation, so it's floating independent to this.
Okay. So it's independent.
Yeah. So the way Takapuna is, it's got this hard rock down here,
Yeah.
and then it's got all this crack. Okay, and that goes down towards Lake Bookie, is it?
Right,
What do you
yeah.
call it?
Lake Bookie, yeah.
Yeah. Now our building is sitting here like this, so you get the rafty stuff because it's only 3 layers. It's quite light.
Yeah.
But you get the tower here, which comes on up, and its piles go right down into this.
And so you had to go that far just to get to the bedrock. If it was up here, you just
It would sink down. It has to go down to solid bearing.
Okay.
So that's what they've done there.
Cost efficiency was important in this project, and therefore the building has a very simple but effective structural system. It is predominantly reinforced concrete construction, with a central core for services, exterior shear walls, and a combination of horizontal I-beams and reinforced concrete beams. Feel free.
Oh, okay. I'll do that. So effectively, you've got a core which makes up, the shear walls, and then around the outside we've got reinforced concrete columns.
Yep.
Around the outside. Nothing too overly complicated because these are connected by reinforced concrete beams.
Yep.
And between that is steel. Okay, there's steel beams wherever they occur.
What sort of beams with the I-beams?
Yes, I-beams. And then there's tray deck between, which is metal like this.
Yeah.
And then reinforcing in concrete forward on it. Obviously there's a thickness of at least 150 mils, and there's sound insulation required. So there's STC around the 60 mark, I think, 55 to 60. It's basically floor to ceiling glass.
Yep.
Around the outside, there's a 2.7 metre ceiling height. Okay, so the interesting thing with the services is the services all come into the core. When you take out the ceiling of the core, it's just jam packed with all the services, all the plumbing, all the wastewater and the sprinklers, everything.
Yeah.
Is out here, so it's all taken out. It's not going down through. There's an exterior. A lot of these decks occur one above the other.
Yep.
So you can see it here. Situation. So any downpipe would just carry on down through, and these ones would connect up, like so, simple as that. So you get a, and all the decks, even the ones that have got the conservatory situation, have got outlets on them as well, just in case. Everything in this building was done belts and braces for weather tightness, because what we have is, we're on a Takapuna, we're sitting here. It's got views all the way around, which is one of the benefits. That's why everyone loves it, because you get to see out to Rangitoto and down the channel, up the channel, and up the East Coast.
360.
Yeah, everything, and back to the city and all the lights and across the harbour ridge and everything. But you also get the wind, the predominant one, the nor'easterlies coming in here about 4 o'clock. But all the rest of the time, all the bad weather coming from here, it's really highly exposed.
Okay.
So, and the winds can get up to, very strong winds. So you get plus or minus 3 kPa on the corners. So if you have a corner like this, you can have a positive pressure on one side, because it's gone past, like with the airplane, it's sucking this side, so it's got the negative pressure. So the skin of the building at the higher levels, especially, had to allow for that. And because we've got wind that can come into the building, right, and hit at great velocity, it can also drive rain upwards. It could drive from any direction. For most high rises in this city since about 1970 or so, the 1980s, since the bad old days of the 1980s, have been relying a lot on sealants. So you have seismic frames with a window in it. The seismic frame obviously allows for earthquakes and any movement. And they rely a lot on sealants.
Okay.
Now, that sealant, when it's exposed to UV over time, has to be maintained or addressed, because it can get failure later on. Now, what was decided to do here is not so much a leap forward as to go back to good old ways of doing it, right? So we've got essentially on the head, the windows have got a downstand on the outside with the drip, so the window's actually tucked in behind that.
Okay, yeah.
And it also, when it comes down here, it's got a step down in the floor and a sill situation.
Right. But
Also behind it, if you look at a section this way, it's got a similar deal on the jambs. Okay, so that's the outside of the building.
Yeah.
At all times, any sealant that we've got, and where the seismic frame is concealed from the weather, so it's a backup thing as opposed to being exposed to the weather, whether it's coming down or whatever. So it was quite complicated in terms of the formwork involved. And obviously it's a bit more expensive to do it that way, but the client was dead keen to have no issues with the windows of this, especially with the exposure it is to the weather. And bearing in mind the people that are buying it, they didn't want any comeback.
Sure, yeah.
So they were willing to spend the money on that. So that you don't often see that, but it was quite a complicated 3D sort of number on it. There's a rebate in behind, and then there's a rebate here. This is looking from the outside. So the window is tucked in here, so I had to do lots of 3D. I did them by hand and worked it out. And then above, in the end, there was some physical, there was some computer modelling and all that done as well.
Yeah.
But essentially, they did work off. I did a drawing like this and said that's the way it should be, and we were setting it up on site, and they did some dummies on site down on the lower level, come along and see the quality of the concrete, see that it all worked and where all the grooves and everything were. Signed it off, and that was the other interesting fact is we haven't got any decks poking out. They're all inboard.
Yes.
And when it comes to the southwest, where the bad weather comes from, we've created like, what do they call them now in Hawaii, where you have a greenhouse situation where you have sliding open windows on the outside, a deck, and then glass on the inside. So basically you can slide open the windows on the outside to create a deck situation, and you can slide open the doors on the inside, so you can have them both
Right.
fully open
Yeah.
or just this open, because all the bad weather that comes from here. You might just want to open this and sit out here in the sun with that, like a conservatory situation.
Yeah.
But on the other sides, it's just an open deck,
Right.
so that's not there. All right. So there's obviously set downs for the deck and drainage and everything else. Thermosash were the window manufacturers.
Okay.
As I say, everything was done belts and braces. We even took on board Connell Wagner. They were facade engineers,
Yep.
and the fellow who did the Petronas Towers, he
Right,
was
okay.
involved. So we did a specification which had the elements that we were interested in, and
Yep.
we subdivided off the specification that dealt with the facade to the Connell Wagner.
Okay.
And they had all these testing regimes that we had to adhere to on the building. One of the things that, and the client also on top of that had testing done. So there's testing done by Thermosash in-house where they have to do their own sort of quality control tests. And then there's testing done where if you have a window like this, and you've got the glazing here, they put a sheet of Perspex up on the inside.
Yep.
You get a vacuum cleaner on, simple
Right.
vacuum cleaner through a hole.
Yep.
They suck out the air in here, so you create a vacuum inside. Someone's had sailed down the outside, he's got a hose, he's squirting water, really, you know, in funny angles and all that, all over at all the different joins. And because it's a vacuum, it wants to suck that water in, so it's making the situation even worse than it would normally be.
Sure.
And every window was tested like that all the way up after it was installed.
Okay.
So you get that sort of stuff going on. Well, up in the roof, we had to conceal the cooling towers, obviously, and the air handling units.
Okay.
So you have the AHUs and the cooling tower. Now the cooling tower has to be able to draw air in, and the steam and stuff rise up through an opening in the top. So there is a bit of a hole in the top.
Yep.
But that also allows the weather to come in. So all this has to be waterproof. Because below this, we've got a 2-level penthouse,
Yeah.
which has got a deck, which is a hardwood deck, over a waterproofing. So we have 3 elements here. We have the waterproofing, which is a membrane. We have on here stainless steel roofing, because the client wanted to glisten like it. Now that stainless steel has to have a certain minimum amount of holes in it, or the microns between the lumpiness. You know, the more lumpier it is, the more it's going to get that tea staining on it. You know,
Right.
terrible.
Okay.
So it's got to be as smooth as, and it never is absolutely smooth, but it's under a certain number of microns. So and that was a special stainless steel. It wasn't just a standard 366. It was a 316, I should say. It's a new one that came out was for that marine sort of situation, because this is all salt laden here and
Yep, sure. Yep.
This here has got a hardwood deck, but one of the concerns here is that when people are leaving around on here having a party or whatever, the sound goes through the other apartments and it's on a membrane. So we had to cushion that deck from this, so it's got resilient mountings. But those mountings had to be done in a certain way that when the wind's blowing here at 200 k's or whatever,
Yep.
that it doesn't suck the decking off. So you also have to be very careful about the furniture. There's a swimming pool up here,
Yeah, we've seen a few of the penthouse.
and when the wind blows, you get waves going on.
Oh,
That's
the pool-
how strong it
The
can
pool
be.
gets turbulent, does it?
Oh yeah, you can do that. And we've got a window at the end of the pool, so that's interesting. And that had to be waterproof from down below. But everything here nowadays you get peer reviewed. The council wanted a peer review, so we had an independent architect that did the waterproofing. We not only had Connell Wagner and all their sort of stuff, we had the Baatjes, this independent thing to check all our details in terms of waterproofing
Right, okay.
and all that. So you go through all this now. The paperwork that you will have to go through when you come out is,
Intense.
yep, and the documentation is massive.